Hello and welcome to episode 6 of the Primary Maths Podcast, the show where we talk all things primary maths. I'm Jon Cripwell.
And I'm Becky Brown.
How are you this week, Becky?
Yes, I'm good, thank you, Jon. It's been a busy week. Last week in school for me this week as well, so there's been a lot going on, but it's been a good week. How was yours been?
Yeah, no, it's been all right. It's been okay. A bit quieter than last week. I've been here in the office a bit more. I think with people breaking up for school and things now, it's lots of people's last week as we're recording this in school. Some other schools, my local schools, don't break up till next week. So they've got a few more days left. But yeah, definitely coming towards the end of it all now.
Yeah, definitely. I remember it very well when you're in full-time teaching. That end is, when that gets there, it's a very well-needed break, isn't it?
I think in every year group it's a well-needed break, but having taught in year 6 for many, many years, sort of staggering towards the finish line for the children and the teachers, I think it's there'll be a few people looking forward to breaking up this week or next. So if that's you, I hope it all goes well. If you've got any last minute leavers services or celebration assemblies, I hope it all goes. So what have we got on the show this week, Becky?
So this week, Jon, we're diving into a topic that sounds complex but has huge practical implications: metacognition. What does it mean to think about thinking, and how can we actually build that into our maths lessons?
Absolutely. And I'm joined by someone who's carved out a rather unique niche in UK education, blending cognitive science, curriculum expertise, and a love of maths. He's taught maths, led departments, written books, and now works across the country helping teachers and schools make metacognition meaningful. My guest today is Nathan Burns, also known as Mr Metacognition, and it was great to talk to him.
In this episode, we explore what metacognition actually means in a maths classroom, why it's not just for high attaining or older pupils, and how teachers can model thinking explicitly.
Just before we jump into the maths of life, just a quick reminder, if you happen to miss last week's episode, I was joined by Kate Frood, a head teacher who never stopped teaching maths. It was a brilliant conversation about leadership, legacy, and the joy of problem solving. So well worth a listen if you missed that one.
And don't forget, if you head over to Twinkle and search for Primary Maths Podcast, you'll find a free PDF companion guide for today's episode, including key takeaways from the interview and links to any resources and reading that we mentioned today.
And as always, if you've got any feedback, questions, or you just want to say hello, you can drop us an email at primarymathspodcast@twinkle.co.uk. Right, let's get into the maths of life. So, maths of life. This is the bit where we talk about maths as it occurs in the world every day, just things that we've noticed or things that we've been thinking about. And so far, we have covered topics such as time, zero, speed cubing, speed puzzling, a slightly confusing look into the world of competitive diving scorecards. And then last week, fractions as they relate to burgers. And so I've carried on the food theme for this week, Becky, because I've been thinking, we started thinking about it a little bit last week, actually, but this week I've been thinking a bit about pizzas.
Okay.
I mean, they're never too far from my heart, I'll be honest anyway. But I was thinking about the maths of pizzas because as we talked about last week, obviously they are circular in most cases. And that gives them some interesting properties when it comes to thinking about maths and the cost of pizzas. So I was looking at a menu the other night for not one of the big chains, one of the sort of local kebab shops that happens to do pizzas and things as well. I wasn't looking at buying one, obviously, Becky. I was just doing some maths research, and they had 6-inch pizzas, which were £7, or you could get a 12-inch pizza, which was £12. So not quite double the price. And my wife said that seems like quite a good deal because, you know, you're getting sort of double the pizza for just under double the price. And I thought, well, that's not how circles work, is it? That's not how the area of circles work. So we had a bit of a conversation about it, because that's what we do in this house. We don't leave these problem solving things to be to their own devices. We talk about them. So I got out some models and some representations,
Of
obviously,
course, yeah.
and put together a quick lesson plan. And but when you think about it, so the 6-inch pizza that had a radius, so that's from the center to the outside of the pizza, radius of 3 inches. So if it's 6-inch diameter, the radius is going to be 3 inches. Now, to work out the area of a circle, we use one of those really well-known, one of the few really well-known equations. I think you've got E equals MC squared, I think is one of the big ones. And then you've got the area of a circle, which is pi r squared. R being the radius, and pi, let's just call it 3 for argument's sake. So we need to do pi times 3 squared. So pi times 9. 3 times 3 is 9, so pi times 9. So roughly 3 times 9, which is 28 inches, or 28 square inches of pizza. Which sounds a lot for a 6-inch pizza, doesn't it, when you think about it? But it's how area works. So if we think about the 12-inch pizza now, that's obviously got a diameter of 12 inches and a radius then of 6 inches. Stay with me here. So 6 squared is 36. So that's 36 times pi, which is about 113 square inches of pizza. So you've gone from 28 square inches to 113 square inches. So it's way more than double. It's about 4 times the size, roughly. And yet it costs less than twice as much.
Yeah, that's amazing. I think I've come across something very similar before when making a circular cake, where you have to sort of work out how much of each ingredient you need to get that extra inch of diameter in the cake is much more than you think it's going to be because of the surface area.
Yeah. So I was just thinking about that and how easily we can be, again, confused, definitely from a marketing point of view and a pricing point of view. That 6-inch pizza probably should have been a lot less money, shouldn't it? But they're charging you a premium for maybe not quite understanding or being bothered to go through all the maths. But I just thought, that's quite a nice way in a maths lesson to show the meaning of area and the importance of knowing the difference between scaling. It's not just twice as big because the diameter is twice as big. It's 4 times as big because of maths.
Love it. How was the pizza?
I told you this was just hypothetical research. It was very nice. Thank you,
Good.
Becky. Yeah, it was good. It was good. We went for the 12-inch one in the end.
Of course.
That was the point
No-brainer.
of the conversation. I had to convince that, there was no point getting a 6-inch pizza. You've got to go for the 12-inch pizza. What's been on your mind this week, Becky?
So I'm going back in time a little bit, John. I'm taking a leaf out of your book today because we mentioned last week, didn't we, about watching lots of sport on TV, and I've been following the Tour de France every day this week. And I noticed that, or sort of was reminded about the fact that in France they use a comma as a decimal separator, whereas of course we in the UK use decimal point. So I was just kind of wondering why that might be the case. I had an inkling as to why it might be because of other areas of maths, but I thought I'd delve a bit deeper into the history. I didn't go quite as far as the Babylonians, but I did go a little way. And I also was just curious, are there any other decimal separators out there? Are there other cultures that use a different separator maybe? So historically, people use this before print. People were using a bar or a stroke or just something to sort of separate the wholes from the parts. The use of the decimal point dates back to 1440. That's quite a recent discovery. They thought it was later than that. Who knew? To an Italian mathematician in some astronomical work he was doing. And then John Napier of Napier's Bones fame used the full stop in the 1600s in his logarithms. And that was then continued, of course, by people who continued that work. So that was where the decimal point was first used. But of course, in France, they were already using a decimal point in print.
They love a bit of decimalisation, don't they, in France?
They do. But they were using it to make Roman numerals more readable. So in print,
really?
they were using it to separate the figures out in Roman numerals. So to aid confusion, apparently, they chose to use a comma instead. And they are not the only ones. In most European countries, a comma is used where we would use a decimal point. There are other options. Sometimes an interpunct is used. Do you know what that is, John?
I have no, that is brand new. That is brand new vocabulary for me.
Yeah, me too. I'd never come across that one. But an interpunct is a decimal point that sits like vertically halfway up. So it's not sitting on the line.
Okay.
Sitting
Yeah.
halfway.
Yeah, I've seen that. I've definitely seen that.
Yeah.
On maybe prices abroad.
Yes.
Maybe.
Yes. So sometimes people use that, but that could add another level of confusion, because in some countries, Germany being one of them, they use that mid dot as a multiplication symbol.
No
so
way.
whereas
what is wrong with an X?
Where we would do 5 and then an X or a multiplication symbol, then a 4. In Germany, it would be written as 5.4. So they wouldn't use that because it would add a little bit of confusion. And then, of course,
I don't want to get political with you, Becky, right? But when it came to voting for Brexit, I was actually in the Remain side of things. But I'm starting to change my mind now, because that's just no, I'm not having that.
I know.
I'm not having that. A full stop is a decimal point.
It's so different, isn't it, to what we're used to? It does show, though, we've talked a little bit, didn't we, about the maths being a universal language, and it shows that it is up to a point. But particularly if you're teaching children who maybe started their education in a different country, you can see where this could be quite confusing. Because, of course, then the issue comes that we use commas, or occasionally commas can be used to separate like sets of 3 digits in a big number. Whereas some countries use a full stop for that, which could make things ever so confusing if you're comparing numbers. And there's even apostrophes. I think in Arabic numbers, there is an apostrophe as that separator. So, so all this led me to this. I've got to read this bit out because I didn't want to get it wrong. But the 22nd General Conference on Weights and Measures. Did you know there was a General Conference on Weights and Measures?
I'll never miss it. Miss it.
In 2003, they said the symbol for the decimal marker should be either the point on the line or the comma on the line. Guess that narrows down a little bit. They also said that for larger numbers may be divided into groups of 3 to facilitate reading, but neither dots nor commas should ever be inserted, and it should be spaces between the groups.
So there was... I remember that there was some arguments about in SATs marking about commas in numbers and whether it should be allowed or not and things. So that's interesting. That's interesting. I think we should get behind a campaign, Becky. We could start it now to have some uniformity, please, across decimalisation around the world.
It would be good, wouldn't it?
I'm not saying that the one that we use is the best, but I do think everybody else should adopt it. Just to make my life easier.
Yeah, it definitely would make things easier, wouldn't it? Going to Europe, you could completely misunderstand the price of something, couldn't you? If there's a full stop where you're expecting a decimal point and it's actually 100,000 something.
And I guess we're only thinking really about sort of Arabic numerals, aren't we? So I wonder what that looks like in other languages that use different symbols for their numbers. Hopefully they use a decimal point, like a full stop.
Yeah, you could find out. Don't do too much digging, John. You will fall in a hole. I fell in a hole this week. But yeah, quite interesting.
Oh, I think so. Thank you very much for that. I've learned something new, and less confusing than trying to work out how to score Tom Daley's last dive at the Olympics. So thank you very much for that.
Okay, so now it's time for this week's guest interview.
Today I'm joined on the podcast by someone who's carved out a unique niche in UK education, combining classroom experience, cognitive science and a flair for making metacognition practical. He's taught maths, led on more able and pastoral work, and written several books including Inspiring Deep Learning and Teaching Hacks, all with the goal of helping students think more deeply about their thinking. Now working across the UK with teachers, schools and ITT providers, he's the face behind Mr Metacognition. My guest today is Nathan Burns and I'm delighted to have him on the show. Welcome, Nathan.
Thank you so much for having me, John. Really excited to be joining you today.
Great stuff. So we normally like to start with just a bit of a delve back into your past, really, all the way back to school. Probably not that long ago for you, Nathan. But how did you get on with maths as a pupil? What were lessons like, primary and secondary?
I don't really remember much from primary mathematics. There were two things that jump out to me from maths in primary. The first being when I discovered I was colorblind. We had a task where it was like 100 colored dots, and we had to produce a tally chart. It seems like a really nice task to produce a tally chart. And I'd always be that kid who was trying to finish their maths work first, and often would. And I took that work up to the teacher, and they said, "No, you're not quite right." And I took it up again and again and again. And I never actually finished that task because I could never actually tell what colours which colour. So I never actually got that tally correct. So I remember that, and I think that was back in year one or year two. And then I remember several years later being taught fractions, and being taught fractions incorrectly because I was taught to add the numerator and to add the denominator. An interesting way of adding fractions, shall we say. Um, and I think, I had a fairly unique sort of schooling experience because I grew up across North Wales and a number of different areas. But then sort of when I was in year five, year six, I was in a year three, four, five, and six class, and there were only 20 odd students in the whole school. So it's quite a unique um, sort of sort of characteristics for that school and sort of how things were taught. And we definitely didn't have um, math specialists within the school. We were lucky to have sort of one teacher in that area to be able to teach us. So that's definitely what I remember from primary. So I enjoyed maths, always did well at maths, and I think it was similar enough at secondary. I did really well, got my A star at GCSE, got my A at A level. Um, enjoyed going into lessons, but didn't, I guess, enjoy it maybe as much as I did at primary. Definitely felt like a lot of rote learning, and I know that maybe it was the curriculum, maybe it's the teachers, maybe it's the school culture, I don't know. We did a lot of sort of, I guess, what we call fluency work now, a lot of fluency over and over and over again. And it would very much be, open up the textbook on page 220 and work through question one until you finish that chapter. And you would, the textbooks would be on the table, ready to go. You'd either remember from the last lesson, or maybe there'd be a quick example on the board, or you'd have a look at the worked model that was always at the top of the textbook. And then you'd do that, and you'd work your way through. Um, and I really enjoyed that because it worked really, really well up until sort of GCSE. And then there'd be like reasoning questions. There'd be some stuff that you had to do problem solving on. And I just really struggled to think outside the box. And it was the same during A level. Again, it was, work from the textbook. And again, where there were fluency questions, worked perfectly well. But where we had to sort of utilize any of that knowledge and actually apply it to anything, really, really struggled to do that. And that was incredibly frustrating, incredibly upsetting a lot of the time as well, just sort of not being able to do it because I didn't have, I guess, what I've now called sort of the mathematical resilience. I didn't know what to do when I didn't know what to do, when it wasn't that non-fluency question. Of course, the curriculum has moved on a lot, exams have moved on a lot, and it isn't that problem solving comes up once in a blue moon. It's an absolute integral part of obviously what we do in lessons, what we do within the curriculum now. But yeah, I definitely remember that, and actually the implications that I had when I started teaching. Actually, I didn't necessarily understand the connections between different topic areas and didn't see why an approach would work in one area and why it would work in another. Because I'd never sort of developed that at school. So I really, really successful, really, really good school, got good grades, but didn't necessarily have mathematical resilience sort of built in due to sort of type of lessons we had, which I think that was fairly commonplace, wasn't it? But that's how maths used to be, really.
Yeah, that was certainly sort of my experience as well of secondary maths. Definitely having a textbook. We're working on this page today. Crack on, off you go. I wasn't a massive fan of maths at school, believe it or not, given that I'm now a maths specialist. So that didn't really work for me. And in terms of primary school, I was at primary school in the sort of late 80s, early 90s. And our maths lessons at primary school, certainly in the juniors, what I remember is that we had these sort of ice cream tub type tubs with boxes with cards in, and you would go up and you would get the next card that you were working on, and you take it back to your seat and you do a bit of work on that card, take it up to the teacher, they'd mark it. I remember very little actual direct teaching
Yes.
going on in primary school, which is interesting. You compare it to what happens hopefully in schools now. Seems quite a different approach.
All the way almost, isn't it?
One thing I just picked up on what you said there about not knowing what to do when you didn't know what to do. I would probably, my definition of a good mathematician now is somebody who knows what to do when they don't know what to do. That's kind of what I would like to build if I was building a mathematician. That would be the sort of end goal. How do we work through a problem even if we're not sure about it? So that's really interesting. So what happened after you left school then?
So,
Nathan,
the main aim originally was to go and work in politics, but that quite quickly changed. So, be the next prime minister. And yeah, I'd studied politics at university actually, so I strayed about as far away as I almost possibly could from my maths really. But yeah, very quickly I fell out of love with that, and thought, right, well, how can I make a positive impact? How can I make a difference? But hopefully a large group of people, and so teaching seemed obvious. It seemed the place to go. And I'd always thought I'd end up being a business teacher because that was the subject that I excelled at the most at school. It was the one that I loved more than anything. And I thought, well, if I don't do business, maybe I'll do politics, maybe I'll do history, because those were my other sort of A levels and other sort of degree areas. Of course, no one really trains business teachers or politics teachers. History teachers, obviously there are, but most of, there aren't that many training courses, and there's definitely not the funding available. So I guess I don't know if it's a selfish choice or maybe a sensible choice, but I thought, well, if I train as a maths teacher, there's the funding there. I can go into that and I'll train as a maths teacher. And then once I've got those qualifications, once I've got my sort of my eye and I know sort of teaching things for me, then I'll change over to teach business. That'll be fine. And check with some people. I said, yeah, of course you can do that. And then I started teaching maths, and then I fell in love with it. And I never did change. I did, the odd cover dance lesson here and the odd dance, P lesson there, but always was just a maths teacher. And yeah, absolutely just fell in love with it. I think I fell in love with it properly this time around when I was teaching it, because I could see the connections, I could see the deeper aims of what we were trying to do with the curriculum. I could to be the one to point out these connections and develop those problem solving skills and those reasoning skills. And some I had to develop for myself the first time round, or sometimes I'd, because of how a curriculum was built, I'd see the reasons, for the ordering of it. And yeah, just absolutely fell in love with it. Did a lot of work sort of on mastery teaching in my second school. And again, that really got me passionate about it, really moving towards that style of teaching. And then, yeah, just sort of worked my way up in the world of maths, I guess, as an assistant head of department, and then lastly as a head of department. So, and I think that was a role I adored doing, because it gave me all of the maths stuff, but it gave me a lot of the curriculum stuff to look at as well, and to really sort of set a direction with the curriculum and really build something that supported students' development and ensured that, I guess, the difficulties that students can have, or maybe some of the experience, it sounds like we've both had in terms of that lack of direct teaching and exploration and problems and everything, but that could actually be sort of should within a really strong curriculum. So yeah, absolutely loved doing that.
It sounds like a great journey, and one I can empathise with a little bit as well. One of the things that you touched on there, I just wanted to go back to, was not being able to see implicitly the connectedness sometimes of mathematical concepts and things. And I think one of the things that we might talk about in this session is about how we can make those things explicit. I know certainly my experience of school was some children got that and saw it. I never did. And that's why things stayed a little bit of a mystery, I suppose, in terms of, fractions particularly. I never understood fractions at all. And obviously fractions I was thinking about this morning, so I was leading a little bit of PD on fractions in different contexts, and we were talking about how in relatively early on in a child's primary education, they're expected to recognise a quarter of a shape, maybe of a circle, a quarter of an hour, and a quarter of 60, and see, all three of those things could be taught completely separately without any overlap, and yet they're all sort of very much connected. So making those connections explicit, I think, is really important, and definitely something we can talk about. So Mr Metacognition then, Nathan, how did that come about? Where did that come from?
Yeah, so my first book, sort of inspiring deeper learning, that was one that really came out of lockdown. So, while people were learning, to bake banana bread and play the guitar and whatever else they could be doing, I just did research, and more research on metacognition. Because I come across it by reading the EF report, sort of the 2018 report, really fallen in love with the theory, because it's complicated, right? It's a really in-depth theory, and the definitions aren't necessarily clear. It just seems to be something that really clicked with me. I just seem to get it, and really, really enjoyed investigating it more, looking at the theory, but also looking at what that looks like in the classroom. So yeah, wrote my first book sort of during lockdown and coming out of lockdown. Then sort of 6 months later, started on my second book, and that came out just a year and a half ago, something like that. Lost count now. And really, the things that I loved, and I sort of alluded to it earlier, sort of that curriculum work, developing that curriculum, really I've always enjoyed sort of teacher PD, looking at sort of how do we get better at teaching, how do we ensure that as a profession we are becoming more effective. And the things that we'll talk about today, John, for some staff and for some schools, they're obvious, and for some, they are brand spanking new ideas. And, but there were schools that are so different, and some things will be so embedded in some places, and some things won't be embedded, but all schools have got an area to work on. And I think that's really, really caught me. It's still the teaching, but obviously the potential impact of sort of teacher PD is even greater than sort of in the classroom. If I could work with 100 teachers who go on to work with 500 kids in that given year, there's a huge sort of impact there. And so I had the opportunity to sort of step out, and I thought, right, if I don't go for it now, I'm never going to go for it. But I've always wanted to go into the world of PD. I've always wanted to lecture, to lead training sessions, to do podcasts, to sort of spread research and practical ideas for the classroom, and look at making teaching better. So yeah, April last year, took the plunge, stepped out of the classroom, making that recruitment crisis and retention crisis even worse, but there we go. And yeah, stepped out and yeah, jumped into PD. And I think the biggest thing I've found is, in the same way that we don't have enough maths teachers, we also don't have enough people to teach the maths teachers. Obviously, a lot of people don't stay in the maths classroom, but equally, there are lots of people who, once they've left the classroom, don't stay in education at all. And actually, there is a significant dearth of people there to actually train up maths teachers, whether they're starting out in the classroom, whether they've been teaching for 10 or 15 years, or whatever that context is. So it's been really, really sort of a great journey, really.
Yeah, so it sounds like it. So that was Easter 2024 that you left teaching, is that right? Yeah. So how was it leaving? How did it feel that first sort of week after you'd taken your whiteboard pens and you'd walked out the door and you'd skipped down the drive? How was that?
I think for the first week I was sort of ignorant of the fact that I still had rent to pay. So yeah, it was for the first week it was sort of like, oh, I could do this, I can have this meeting, I can do this, and then I think reality quickly set in, but I needed to sort of get some jobs and get some schools to work with. But it all worked out in the end, and come sort of September the 1st, I was sort of delivering school inside. I mean, I was fortunate; I'd already written a couple of books, sort of knew quite a few people because of that. But yeah, it was, and it still is weird. And I guess a lot of people say, is it strange not being in the classroom? Is it strange not being in there with students and teaching them all the time? And it is to an extent, but equally, I'm constantly in classroom, but teaching teachers. So I'm still teaching. I'm still doing I do, we do, you do. But it's just with an adult teacher audience, looking at how we teach more effectively, as opposed to teaching fractions or teaching thirds or teaching negative numbers or whatever it might be. So similar but different. But yeah, that first week sort of, it was a bit of a whirlwind, and it was for several months actually. It still feels like it now sometimes. It's sort of still a bit of a pinch me moment of, oh, I think got to go and find a school to work with, or this or that. It's all yeah. Sometimes the lack of routine in many ways is still quite strange.
Yeah. Yeah. No, I can empathise. So let's get back to metacognition then. For the uninitiated listener, what is, it sounds like a scary word. It's definitely not everyday language. What is metacognition?
Yeah. So I think the definition we often come to is thinking about thinking. That's what a lot of people would say if they had to, they had to put something down as a definition. They'd go, right, it's thinking about your thinking. And it is that, but only to an extent. I think that's quite a shallow understanding of what metacognition really is. The definition that I always go to, it seems to be quite heavy, but there's a definition from Flavel in sort of the mid-70s. And Flavel wrote that you're being metacognitive if you notice that you're having more difficulty learning A than B. And I think what Flavel's really getting at in that definition is, say you've just answered 10 questions, you've 10 questions are on the board, you've answered the 10 questions and you've marked them. It'd be very easy to go, oh, I got 7 out of 10. That's all right, and move on. Or you go, oh, I got 10 out of 10. Yeah. I've absolutely nailed it, and move on. Or you go, I got 9 out of 10. I wasn't really trying. I'll just move on. It doesn't matter. Actually, metacognition is evaluating why something has gone as it has done. Why have you got 0 out of 10? What's gone wrong? What haven't you quite understood? What is it that you need support with? What is there a concept that you haven't quite grasped? Is it because you haven't done the homework? Is it because you've been revising in a really noisy environment? What has meant that you haven't been as successful as you could have been? On the flip side, if you just got 10 out of 10, well, why? What has gone particularly well about that test or that exercise that has meant you've got 10 out of 10? What can you learn from that? Because obviously things have gone well, and there are some things that are going to be consistent, but you're going to need to do in other questions. So maybe you've got 10 out of 10 because for the first time you've actually laid your work out as the teacher wanted you to, and the answer is really obvious, so the teacher can actually give you the mark. So maybe that's a thing that you're going to carry on through. Or maybe you've just really understood, maybe the grid method for multiplication. You hadn't done it like that before. So actually, breaking numbers up like that, or when you're introducing algebra, you've realized that's a really good strategy for you to use, and you're going to keep using that. Or maybe you've just cracked Venn diagrams, and now LCM and HCF and prime factorization, or whatever it might be that little bit more straightforward. So it's about identifying those things that have gone well, and you want to keep the same, or those things that haven't gone well, and you want to adapt. And then,
okay.
Flavel also...
Sorry, no, go on, Nathan.
Don't worry. At the end of Flavel's definition, he also says, if you feel like you should double check C before accepting it as fact. And I think that's particularly pertinent to maths. To me, it's that idea of, well, again, you've answered those 10 questions. And maybe answers 1 through to 9, you've got a whole number, and it's positive. So, so what do you expect at question 10? You probably expect another whole number, and you probably expect it to be positive. It's probably going to follow that pattern. But what happens if that final answer, the answer you have for number 10, is a negative number and it's a decimal? So maybe before you accept that as correct, maybe you go back and you check the workings you've just done. Maybe you double check that you've not had any miscalculations. Maybe you just compare it to your other answers. Or maybe you go back and you go, well, actually, I'm really confident about this one. Well, maybe 9 and 8 and 7 aren't correct, because maybe actually some of those should have been decimals, or maybe some of those should have been negatives. So it's also this idea of sort of self-evaluation, of understanding, well, does this look right? Does it seem to fit in with the pattern? It's that deeper sort of, and that wider mental model that we know makes the mathematician is beginning to develop those connections. And I think Flavel kind of captures that almost as like gut feeling. Does it feel right? But obviously, does it feel right is a very academic, or in our case, a very mathematical thing that you've got to consider. So I think that definition helps us quite a lot really understand what metacognition is that it's this idea of planning how we're going to do something, of keeping an eye on whether it looks right, whether we're going in the right direction, and considering at the end why something has gone or why it hasn't gone to plan, why we haven't achieved the mark we wanted, and what we're going to do about it later, and feeding that into sort of future tasks and future plans.
That's a really good, clear definition, Nathan. Thank you. And I can imagine lots of listeners will be listening to this and thinking, yes, I absolutely would love my Year 6 children to look at the work that they've done today and reflect upon that work and think, oh, I found question C slightly harder than question B. I wonder why that might be. But in practice, what does that look like in a classroom? Because it's something that sounds like it requires a level of maturity to undertake.
I think that's a really common thing that people will say. I mean, one of the biggest myths around metacognition is that either the students need to be really academically able, because how can you start to do the meta if you can't do the cognition? In effect, if you can't even do the maths, how can you start to evaluate it? And there's a semblance of truth to that. I'll come to that in a second. All is this idea that, look, they're too young. They're in year 6, they're in year 4, they're in year 2. They're just not old enough yet. It's a complicated thing. And again, there's a semblance of truth to that, but again, it's not the whole story. So I think in the first instance, that idea of, maybe they're not level they need to be, maybe they need to be GCSE students, or they need to be the very best kid in the class, they need to really understand things really well. I mean, I understand that, because if you're really struggling with the maths, starting to evaluate what's gone well and what hasn't gone well can be quite difficult if just everything is wrong. But metacognition isn't just about evaluation. It is about that planning and that monitoring of your tasks. So before you begin, we're talking, I said earlier sort of that knowing to do if you don't know what to do is a deeply metacognitive thing. And actually you're given a problem or you're given a task, and actually breaking that down and understanding the keyword. If the question says solve, if the question says triangle, it says parallel lines, solve math specific language. What does it mean? What do I need to do with it? Maybe let's use the model that the teacher's done on the board. What's similar? What's different between those things? How might I substitute the numbers I've got for this question into the model that the teacher's done? Again, it might seem commonsensical. That's all metacognition. It's considering what we can and cannot do and how we move through the process. So I think at any sort of ability level, at any attainment level, those metacognitive skills are imperative, because planning occurs whether you're the top student in the class or the lowest student in the class, and it occurs within any topic area, any cognition that's happening. So I think that's the first thing. I think the second thing links into that. Then they're not at a level they can be metacognitive. We're just using number lines, we're just trying to do addition, we're just trying to do this. They're all cognitive actions. They're all requiring a strategy. I mean, when we start to teach kids to count, how many different ways do we show them, with counters or with blocks or with fingers? Or we start to teach students to add, and you might go, right, well, you can use fingers to do 7 plus 3. But as soon as you get to 7 plus 4, you can't use that. You need to be using something else. You're using counters. Or even just that sense checking, the definition we talked about, double checking C before accepting it as fact. So if I do 7 plus 4, I know it's 11. But how do I know it's not 9? Well, I know that 7 plus 3 is my bond pair that gives me 10. So if I've got 7 plus 4, it must be more than 10. So I can't possibly be 9. It's got to be more than 10. And that itself is deeply metacognitive. So it doesn't matter sort of what attainment level we're at. It doesn't matter what age level that we're at. Any cognitive action in that given class or within that given age group is going to be the next most difficult thing for them. And so there are going to need to be strategies, and there are going to need to be approaches that the students develop that start to sort of develop them as mathematicians. Because, of course, like you say, Jon, when you were sort of reflecting on sort of maybe your own schooling and fractions, and you maybe do fractions of a circle and shape them in, or you do fractions of time, and you learn how to tell the time, and then you do fractions of amounts and whatever it might be. And actually, it's only sort of later on we can see the connections between them. But ideally, that would be something you'd start to see straight away. You'd go, well, if we split a circle up into 8, we could do that with a clock, and that maybe helps us tell the time. Or we can split it into quarters, and like we've got quarter past, half past, quarter to, etc. So actually, at any age, we've got the most difficult thing, and all of those areas have something that is now obvious to us as improved mathematicians. Of course, you can split a circle up, and that helps you. You can relate that to telling the time, and splitting up 60 minutes can help you start to work out fractions as well. Of course, that's obvious to us, but at some point, the kids were teaching that brand new information, so we need to develop that sort of that cognitive resilience and start to develop those strategies.
Do you think metacognition is something that children do intuitively? I'm just thinking about I was lucky enough in the last school that I worked in, it had a nursery provision, and it was brilliant. I mean, I was terrified of going through that door for about the first 5 or 6 years that I was there, but eventually I got over that fear, and went through and spent some time understanding what was happening mathematically in nursery. And there were the explanations that some of the children gave you without even prompting about why they knew what they knew or what they'd noticed was brilliant. And I think actually we ended up losing some of that as the children came through school, and we had to try and retrain them to do those things that they'd intuitively done at the age of 4, and were just excited to tell you why they knew that there were 4 pens in the pot, and that number on the pot was number 4, and that's why they put 4 pens in there. That sort of thing they sort of did intuitively.
And I think that's spot on. And I think it's due to almost the rigidity of what we're teaching. The lower down you go in school, the more opportunity for open play there is and open exploration. It's interesting. As the years gone on, I've done more and more and more work with early years. And it's because it's such a, I don't want to say easy because it's never easy, but it's such a gateway. It's such a fantastic way of getting metacognition in there, because the more open you are, the more strategies you have available to you, the more approaches you can take, the more evaluation you can do, the more consideration and comparison you can do between approaches, the more exploration there is, the more metacognition there is. Imagine if you're cooking something now. If you're very, very rigidly following a recipe, your metacognitive consideration might be, well, actually, I didn't do stage 4 properly because I didn't beat the eggs sufficiently. But maybe that's it. But if you just went to the fridge and sort of did a bit of a ready, steady cook and threw 6 ingredients down on the counter, then there's so much metacognitive. How am I going to chop up this courgette? How am I going to fry it off? Do I use butter? Do I use oil? If you're using a recipe, it's dictated to you, right? You're following that, and hopefully you get the product that they're looking for. Whereas when you ready, steady cook it, you're making so many of these decisions for yourself. And I think we can probably
that's such a good analogy, Nathan. I love that. Yeah, really
good. Apply that to primary, and as you go through early years up, we move more away from the just here's your bag of stuff, what can you do with it? So I'm going to teach you this, I'm going to teach you this, and then as we keep going, and you get up to age 16, age 18, and it very much is, well, here are your 10 steps. The only thing that's going to change each time are the numbers. Learn those 10 steps. They've got to be in that order, and there's nothing to discuss here because it must be like that. Which is why I do think we have to both retrain ourselves and retrain our students, because, I think there's some level of it's sort of intuitive nature, metacognitive nature going on. But equally, I think it's easier for us to have those conversations. I think it's very hard to be in an early year setting without going, oh, why have you done it like that? Oh, could we use different objects to build that tower? Why do we think that's strong? How many tall is it? What if I took out one? How many blocks? Those conversations, but as we go on, we've got to make sure we keep doing things like that, and that keeps it going with the kids. And as soon as we stray from that, I think kids lose that thought process because it becomes more and more and more closed, and so there isn't the obvious opportunity to plan or to monitor or to reflect.
I wonder if part of it is around pace as well in terms of curriculum coverage, because I think in my opinion, a wonderful thing happened in early years about 4 years ago, which was that the framework was revised and the focus was very much on really exploring and understanding number to 10. And so you've got lots of things to do in early years, but in that reception year, you've got a year really to really pull apart those numbers and play with them and manipulate them and see what you notice. And I know from experience that as soon as you move into year 1, suddenly we've got this absolutely crammed full curriculum that you've got to get through the year, and therefore having that recipe, as you say, to help follow, to make sure that you get through that, maybe that leads to some of that constraint.
And I think that's completely true. I was doing some training early on today with some secondary trainees actually, and we were having a look at rich tasks, and there were some really good tasks we were looking through, and the trainees were going, oh, I can see how this would link here and link there, and this would be really good to develop this skill and develop that skill, and I'd be great for this. And then sort of the conclusions at the end were, this is all great, but we just don't have time to do it. So, okay, bye. And it's sort of, there's such rich, pardon the pun, such rich activity out there, such fantastic resource that allows us to sort of keep this mathematical exploration going. But we end up having such a packed curriculum, and we end up having so much to do with so many students, with so few resources, that it becomes really difficult to almost push back and sort of follow that. I always sort of call it the go slow to go fast. Actually, if we embed
Yeah.
those building blocks, it's a lot easier to learn how to divide something into a fraction later on. If you've actually played with manipulatives, physical manipulatives in earlier years, and you actually understand the concept of a fraction. Because if I actually understood the concept of a fraction, would I have believed the teacher when they said, "Oh, you must add the denominators together"? Probably not, because I'd have understood what a fraction actually was demonstrating, whereas I didn't. So what did I do? Well, I just added the denominators together. Because that was the way there was no double checking. See, it was like, I don't really know. I'm just going to do this. So yeah, I think the
Yeah.
more open-ended we can be, and it's difficult, and I think it takes great bravery to push back against those demands and sort of realize the type of activities that work lower on down school and how we can consistently embed them as we go through the higher years and ensure that we still have those opportunities for discussion, for exploration, for inquiry, for interrogation, for discussion, for debate. Mathematical debate is a fantastic thing, but how often do we actually have that? Do we have students go, "I think it's like this"? Well, I think it's like this. Why? Why? Or do we just go, "Actually, the right answer is this. Let's pick it and let's move on"?
Yeah. Yeah. You're wrong. You're right. Well done. Off
Yeah.
we go. Um, so, okay, let's go back to the teacher in the classroom then. They've agreed with everything you've said so far, Nathan. This all sounds brilliant. We can agree that the practice in early years sounds great. I'd like to do more of this. I'm currently working with we're a teaching for mastery school. I'm using a scheme of learning. The lesson is sort of mapped out for me. How do I get these metacognitive concepts and practical strategies into my lesson?
So I think there's a few things that we can do, and some will be teacher led, and some will be teacher placing the onus on students, and some of them are invisible, and some of them are visible as well. And sometimes it's easier to do the visible teacher led things, but I think as we're lower down school, it's actually easy to do the invisible things. So I'd always start off with really carefully thinking about our modeling, because it's very easy. And if we've got a really effectively planned lesson, it's very easy to go, "Well, this is a good example. I will use this example." So, whatever topic you're doing, whether you're doing fractions, you're going to start off with fractions amount out of 100 because it's a nice number to be working with and you can break it down quite nicely, or whatever it might be. So, it's very easy to go, right, I've cognitively, it's planned out very well. But when we're stood there in front of the students, we're not just modeling the maths, the actual sort of the cognitive actions, you do this, you do this, you do this. We also need to be modeling the meta aspects of it. So why am I using this strategy? Why am I focusing on this word within the question? Why is that the first step I'm going to? Why am I stealing that strategy that we used 4 weeks ago? And very often, I was speaking to a couple of teachers yesterday, actually, they were working in a junior school and they were looking at metacognition across the board, but I think it's still really relevant to this conversation. And we said that actually, almost like when the going gets tough, when you're tired, when you're ill, when stuff just needs to be done, what do we end up doing? We just go back to the model and making sure that students have got the core knowledge. And actually, we need to keep challenging ourselves and keep going back to, well, why am I modeling it in this way? Why am I starting with this step? Why am I focusing on that keyword? And I always think, well, if something is automatic to me, of course I'll use this strategy. Of course I'm going to lay it out like this. Of course I'm going to highlight that word. If it's automatic to me, but it isn't automatic to my students, then that's the metacognitive teaching. That's the metacognitive gap between myself as the expert and the novice is sat in front of me. So I think that's the very first thing. What metacognitive choices are you making as that expert at the front of the room that are obvious for you, but are not obvious for your students? And hence you need to illuminate those ideas and those choices to your students, because without it, that metacognition is not going to develop in young people because it's still invisible.
I suppose my analogy for things like that, when I've been talking to trainees and to teachers and things about this concept of automaticity and teaching things that you might implicitly just be aware of and take for granted. It goes back to learning to drive. So now if I jump in a car, I switch the engine on, I put the seatbelt on, I release the handbrake, it's in gear, I'm away. At no point am I thinking about any of those steps. I'm just doing it. And, my daughter's in the back watching, and she's taking in some of these things. She has no idea what impact actually changing the gears has. She doesn't understand that. She knows it's something you need to do, but she doesn't understand actually what's happening. And so, when one day she comes to, God forbid, everybody out there, one day when she comes to learn to drive, I'm saying this because she's terrifying just on 2 feet, let alone behind a wheel of a car. But when she comes to learn to drive, she's going to have to think about those, but they will eventually become automatic as well, won't they? So this idea of thinking, we don't always continue thinking about these things, do we? At some point they become internalized. But as a teacher, these metacognitive practices are really useful for our own thinking as well, aren't they? Not just the students.
Well, this is it, absolutely. And if we're driving the car and we never explain why we're changing gear or when to change gear, the person who's trying to learn to drive isn't going to be able to do it properly because they're not having that invisible thing explained to them. And it's the same in the maths classroom, isn't it? So that's the first thing that we can do. And I think just keep teaching ourselves, not explaining the automatic thoughts that we're having and the automatic processes is crucial. Which I guess brings me on to the second thing I'd always say we can do is there's typically more than one way we can model something. Sometimes there is only one reasonable, logical way of going about something. But very often, we're very blessed within our subject area, aren't we? That there's normally more than one way of doing something. And sometimes we can do it more concrete and we can use manipulatives. Or sometimes we go for a more abstract option, depending on our case, depending on it, blah, blah. But actually, the more ways we demonstrate to students to do something is mathematically beneficial. If we can show students there are different ways of getting to the same point. But it's more than that. It's also explaining, well, when might you use one approach? When might you use a different approach? So if we're introducing multiplication, we might start off by doing repeated addition, right? If for the very first time you do 5 multiplied by 10, you might have a look at the idea of, well, actually 5 multiplied by 10 is 10 and 10 and 10 and 10 and 10. Oh, it's 50. But later on, when students are doing 41 lots of 57, you do not want to be doing additional, repeated addition of 57 41 times, do you? So does repeated addition as a multiplication strategy hold water? It does. Do I still sometimes use it? Absolutely. Sometimes if you just want to double check something, if you're just completely having a moment where your brain's not working, you just do a bit of repeat, or even sometimes it's just you're in the supermarket, something costs 39p, you're getting 3 of them. What do you do? We go, well, it's basically 40, 80, £1.20. If you want to be precise, knock off the 3p, it's £1.17. You wouldn't actually go to a formal written method. So something like multiplication, there are so many methods, and they've all got a time and a place to use them. And maybe as we go later on, a quick method is more commonly used, but they've all got a time and a place for us to use them. I always think of, there's a question I love to use in sessions. And the question I use is 8 multiplied by 0.3. And I just say to people, well, see how many different ways you can work out the fact that that is 2.4. We know that that's equals 2.4. Well, how many different ways can you do that? And I think all of those different approaches you've got, and I think the most I've got from one group before is 14. There are a lot of ways to do it. Of those 14 ways, they've all got a value to them. They've all got a place. And at some point, we probably use each of those 14. Or students might try and use each of those 14, because one of them is, get rid of the decimal and just lob it back in somewhere. We know that that's something that students do with multiplying decimals. We know it's not great, but they do it. So actually being aware of that approach and going, well, what are the weaknesses of that approach? What are the strengths of it? When might we use that approach? So I guess in total, what I'm trying to say here is we're in a subject where there are lots of different strategies for the given model we're trying to provide. And actually not just taking the time to model them, because yes, it makes them mathematically better, but taking the time to model and evaluate those different approaches and identifying the strengths, weaknesses, and sort of utility of those different approaches, so that students have that more rounded mathematical understanding, but also that deeper metacognition of, well, actually, this is the type of question I've got. I'm going to go about it like this, rather than, here's the question I've got. I only know one way of doing it, so I'm going to shoehorn the strategy for the given question, which again, we've all seen students do that, haven't we? They've got one way of doing something, come what may, and they use it regardless of the question they've got.
Yeah, and there's always that sort of frustrating, as somebody who worked in Year 6 for a long time, we'd have a Year 6 arithmetic Key Stage 2 test, SATs paper, and one of the first questions would normally be something like 6,001 add 1,002 or something very straightforward. And you would see children writing that out as a written method, or something like 1,000 take away 999, and writing that out as a written method and just thinking, there's so many opportunities to go wrong here.
Yeah.
You know that, 1,000 is one
more
than
999.
There's
value columns and you go,
exactly.
No, something's going to go wrong.
Yeah. Yeah, whereas if it was taken out of a context, taken out of a maths test context, and you said, there's 1,000 people in a stadium, 999 of them leave, how many are left? I guarantee you every single child there would have been able to say, well, there's one, without turning to a written method, but it becomes a safety net, doesn't it? Those are two fantastic tips, Nathan. Thank you very much. One thing I wanted to talk to you about, I did mention this off camera earlier. As I'm going into schools and I'm working with schools, I see a lot of PowerPoints being used, and I'm not against PowerPoints at all. I think they're a useful way to structure a lesson. But when it comes to pictorial representations, I think I am developing a little bit of an issue about over-reliance on PowerPoints for some of the pictorial representations that we want children and students to use themselves. And we're representing those by putting them on a screen, pressing a button, and it changes from one representation to another, or a line appears from somewhere. And it seems very much like magic. I was always, I still am very much more of the opinion that there's a benefit to actually constructing the models alongside the children using a whiteboard, or flip chart or something like that. I'd be really interested in your thoughts on that, though. Is that just something that I'm making up, or is there some sort of actual theory behind that opinion?
I love a PowerPoint. I absolutely love a PowerPoint. But for me, PowerPoint it contains the structure and the key core elements of your lessons. So what I would look for in PowerPoint, and when I was producing my PowerPoints, is the models that I wanted to give to students. I would have predetermined the examples that I wanted to provide. So, if I was demonstrating multiplying decimals, I know that I want to use my 8 multiplied by my 0.3, and then maybe after that I want to do my 0.7 multiplied by 0.4, by 4, sorry, or whatever it might be. So I've got my key things in there, because what we don't want to do is walk into a lesson and on the spot go, I'm going to model 1.5 multiplied by 2.2. And actually, it's not the best model.
Absolutely.
So having that core structure within a PowerPoint of this is what I'm going to model, absolutely. I think that's really, really helpful. But I completely agree with you. But then clicking through each stage of work, and it's like, and so step 1 looks like this, and step 2 looks like this, click. And this is what it looks like with counters, click. This is what happens when you split up a circle into 16, click. I think there's sometimes a time and a place, but actually, I'm a massive advocate of visualizers. I mean, it feels like since COVID, they somewhat gathered dust again. It's like they've gone away with that. They were gathering dust. Visualizers, getting those counters under a visualizer, getting the number line under a visualizer. Actually, the example of 8 multiplied by 0.3 comes up on the board. And I'm going to model each of those stages. And I think without that ability to be, I call it explicit justifications, that idea of sort of really modeling our own metacognition, it's very, very hard to do that if you're just clicking through a slide. Whereas if you go, right, I've got 8 multiplied by 0.3, the first thing I'm going to do is I'm actually going to turn my 0.3 into a 3. I'm going to make it 10 times bigger. I'm going to demonstrate that with a little arrow and a little multiplied by 10. And the reason for doing that is because decimals are a bit fiddly, so I'm going to turn it into an integer. An integer means a whole number. And now I've explained my first set of workings, and I've written it down. That is developing the student far more than going, let me just press click. Oh, look, we're doing 8 multiplied by 3 because 3 is easier. Okay, move on. Oh, that's 24. Oh, So I think it's far easier to be clearer with our mathematical modeling, and it's far easier to develop metacognition underneath the visualizer by physically using the indicators. Because like you say, John, in your car example, the gears and putting on and off the handbrake and indicators, all of these things are automatic. When we're clicking through, it's all automatic to us. But we're missing those things that novice learners might not know, might not think about. So I think it's safer to model those things step by step to get things into the visualizer. And I could walk into dozens of classrooms and people use PowerPoints and they do click through things and they are explicit in those choices. Absolutely. But if we're thinking about the most or the safest ways to model that, I think it's far easier to model things in depth and to talk through the choices we're making and to explore manipulatives under a visualizer or a number line on a flip chart board or whatever it might be. Far easier to do that in live time rather than having something sort of pre-created that we're clicking through.
To me, and I agree with everything you just said there, to me, another analogy I would draw is, if we're trying to develop children's vocabulary, we want them to use math-specific vocabulary, we want them to use, in Key Stage 2 or even Key Stage 1, the term sum when we're adding two numbers together, or product if we're multiplying numbers. We need to model that ourselves out loud.
Yeah.
We can have it on the board, and we all know working walls. We can put lots of language on working walls, but if it isn't actually explicitly modelled, used in the correct context by the teacher, it's very difficult then to expect the children to just do that off their own bat, if you like. So for me, I just think that the opportunity to co-construct some of those models that we are then going to ask the children to use themselves, that just seems logical to me that you would do it that way rather than, unless we're giving them all a PowerPoint. I think it just makes sense to show them your thinking, and it gives those opportunities for doing those things along the way. So you're doing a lot of work with trainee teachers and ITT providers and things at the moment. What do you think would be what do you think early career teachers or newly qualified teachers or teachers who are training, what do you think they should understand early on about metacognition, particularly in maths? Is there sort of one place that you would suggest that they should start building good habits?
I think it goes to that modeling and thinking very carefully, because at the start of your career, everything is, I'm going to model it like this, I'm going to do it like this. And sometimes you sort of double question, you question yourself and re-question yourself. Am I doing it right? Am I not? Is it like this? And I think it's really important early on in your career, get into the habit of making those explicit justifications. I'm doing it like this because. And it is difficult. And as your subject knowledge grows, it will become far easier. And as your knowledge of alternative strategies and of stats and curriculum grows, it will become easier. But I think try and get into that habit of, well, actually, I'm focusing on this word triangle because instantly I know that my shape must have three sides or whatever it might be, whatever the context is. Really start to justify the decisions that you're coming to rather than just saying, oh, I split into 8 and then I shade in 1. Actually, why am I doing it like this? Why am I using a ruler? Why am I splitting it up like that? Why am I using a triangle? Whatever it might be. Really taking the time to justify the choices you're making and trying to share that additional expertise you've got as an expert, because you might not feel like you're an expert all of the time, but actually you are compared to the 11-year-olds or 8-year-olds or 4-year-olds sat in front of you. You are very much the expert, and actually taking the time to explore and explain the decisions you're making is just so incredibly powerful for students. And it's better to get into that habit earlier on in your career than sort of trying to change habits later on.
Yeah, so good. I think I'd probably just echo that really. And one of the things that because I do some work with skit students and things as well. One of the things that I'm sure you've heard this, I think this is basically another way of saying what you've just said, really, but trying to get into the habit of asking yourself, what do I want them to notice by doing this task? What is it that I'm trying to draw attention to? Absolutely. Rather than what is it that I'm trying to teach, or what is it that I want them to do? Just asking that question, what is it? Why am I doing this? What's the purpose? What do I want them to notice? I think is a really good way, as you say, of getting into those good early habits. So our time is drawing to a close. We do like to traditionally finish with 4 quickfire questions, really.
Yeah.
So first one of those is, other than your own, Nathan, because that goes without saying, what book or blog or podcast or resource should every educator, in your opinion, be aware of?
I think that the thing that I always say to trainees is Resourceaholic. Joe Morgan's Resourceaholic. It was always my go-to place for those rich tasks, those problem-solving tasks, those reasoning tasks. And actually, if you need a bank of resources that you can trust, it's a great place to go. Joe Morgan's a great speaker. If you ever have the chance to hear him speak and go to any of the training, absolutely fantastic. But it echoes a lot of what we said today and a lot of what I imagine, what we'd end up talking about if we had another several hours. Actually, those really high quality tasks that really stimulate mathematical thinking, but really allow you to read in between the lines of the maths that's going on. It is really, really good sort of source of high quality questions and resources.
Fantastic, and maybe, Nathan, one day if we've got a bit more time, we'll come back to some of those.
Absolutely.
Because that sounds like another great conversation. Second question then: one thing that you've changed your mind about in education in the time that you've been involved in it.
Oh, this is going to stir up some controversy. Silent corridors.
Great.
That is the big one.
You like them, or you
I love
avoid
the
them?
silent corridor. I think I hated them until I saw them working in action and read more about where they'd worked really well, and then have become an advocate for them. Ever since, yeah, there were many benefits of them. I know it is a very controversial sort of area. It definitely brings me back to sort of 2021, 2022, when a lot of schools had to have them, whether they like them or not, due to COVID. Some schools have kept them, some schools couldn't wait to get rid of them. It's very controversial, but I'm a big fan of the sense and the safety that they can bring to corridors, that I think is definitely required in a lot of schools. I think that can definitely help to bring that to certain schools. Yeah.
Interesting. Thank you. That's the first time that one's come up on the podcast, so I'd be really interested to hear what people think about that one. The third question is just a daft one, really, but a number that has meaning to you, or is just your favourite number, and if there's a reason for it.
I love 64. Just so many different ways of getting to it. There's just so many ways. Yeah, so many ways we can get to 64. Square, cube, powers of 2, etc. It's just, good number to be able to manipulate and do a lot with. Interesting for prime factorization as well. Just really, really fun number to play about with.
It's a great number. I'm with you. And then finally, just to wrap things up then, Nathan, one small thing that you feel makes a big difference in the classroom, something somebody could put into place tomorrow and it would have an impact immediately.
Oh, there's so many things to choose from out there. I think the biggest thing, and I think this is a non-maths thing, is just emotional consistency. And and that doesn't mean you've got to be the kindest teacher in the world or the most strictest teacher in the world, but ensuring that when those students come into you every single morning, they know what they're going to get. And it is really difficult because we've got lives and emotions ourselves. Actually, the more consistent we can be for those young people, many of whom are coming from unstable homes, and unstable homes sounds not quite right, but from homes where maybe they don't have that consistency, they don't have that stability. There's a whole plethora of reasons out there, but actually school offers that consistency that almost the rest of life doesn't offer. Unless you have a very, very regular 9 to 5 where the same things happen every day, actually school is the next closest thing to that consistency. And actually having that consistency yourself and students knowing what they're going to get from you. I just think that's absolutely huge and can be really, really beneficial to teachers at any point in their careers.
I think that's absolutely fantastic advice. And if you are a primary teacher who spends 4 or 5 days a week, 4.5 days a week with your class, you spend more time with them possibly than they do with some of their family quite often. So you do build those relationships, and having that emotional stability, as you say, I think is something that's easily overlooked, but really, as you say, can make a big difference. So thank you for that, Nathan. That's really great advice. So just to wrap up then, if listeners, I'm sure they would want to hear more from you, where could they go to find out a little bit more about your work and find your books and things? Where's the best place to do that?
Probably just my website. So just mrmetacognition.com. It's got links to sort of all my blogs, other podcasts, online training. Links to all of the books are on there as well. So yeah, that's a pretty good one-stop shop. And I've got some sort of like previous conference talks I've done on there as well. So there's a little bit of PD available on there that people can dig into. Some more general, some metacognition, some maths related. So yeah, there's some stuff on there that hopefully will give people some interesting listening and some further reading.
And I can vouch for that. It's a fantastic website, and almost uniquely amongst educators, actually looks like a nice website as well. So well done for that. It's it's a nice place to go and visit. So definitely check that out if you have chance. Thanks so much, Nathan. Really appreciate you taking the time to have a chat with us today, and looking forward to hearing about people putting these things into practice. Thanks a lot.
Amazing. Thank you so much for having me, John.
Huge thanks again to Nathan for joining us and for sharing so many great ideas.
This is the part of the show where we discuss key takeaways from the interview that you might want to use in your own school or your own practice.
So, Becky, what did you take away from that conversation with Nathan?
Well, one of the first things that struck me, John, was Nathan was talking about not knowing what to do when you don't know what to do. And I think that just highlights really the importance of teaching the how and not just the what. I think in maths sometimes there is so much content to get through, isn't there? You can get very bogged down in, we have to teach this information, this and this and this. And actually, there is it's really important to teach those skills of how to do things and to teach the very important skill of resilience and being able to keep trying something which I think, any experienced teacher will have experienced a lack of resilience maybe with a challenging problem in maths. But yeah, it really highlighted the importance of teaching that and not just expecting children to be able to be resilient when faced with a problem.
Yeah, absolutely. I think resilience is a conversation that comes up again and again and again, and some of the ideas that he shared might be a good way to start to tackle some of that. I really enjoyed our conversation around modelling ideas and representations, and the importance of the teacher thinking aloud whilst they're doing that. And again, just coming back to that idea of PowerPoints being really helpful and really useful and things, but there being a separate skill almost in creating a representation alongside the class and actually modelling your thought processes as you go through that process, I suppose, of creating the model and really linking it to what it represents in the problem or in the maths, so that those links are made explicit. And I think a lot of what he was talking about really was about making things explicit that might otherwise be implicit, and that was part of it for me.
Yeah, I think you can assume, can't you, that it's something that's just known. But by thinking aloud, often you're sharing things that maybe children weren't aware of. Yeah, it just comes back to those making connections, doesn't it? And I think modelling alongside the children is just a perfect way. I mean, we've both taught year 6, talking to children about making sure they're jotting and drawing and anything they can on that paper at the end of the year to help them with their maths. But it's making sure that they know how to do it. So yeah, I agree with that, John. One of the other things that I noticed was when Nathan was talking about, when you've got to the end of maybe a set of 12 questions and you've got your answers and you might think about them, I think we're very good at encouraging children who have struggled or made mistakes to think about what they've done and what their thinking was. But I don't think we're very good, or this is from my personal experience, at trying to unpick things with children who maybe got them all right. I think sometimes you can think, oh, you've got them all right, that's great understanding, move on. But actually, he sort of said again how important it is to do that picking apart with everybody. It's not just for those children who maybe have found something a bit tricky.
Yeah, it goes back to what do you value, doesn't it, as the teacher? Are you just valuing the right answer, no matter how we've arrived at it, even if it's purely luck? Or are you valuing the understanding and the sort of internalized structures of the maths, which is really what we want to pass over to the children, isn't it? I guess to the pupils, what we want them to have is that deeper conceptual understanding. So if every time a child gets a question right, we just say, "Yep, well done," have a merit point, and move on. Then you're losing that opportunity, aren't you? Potentially to really unpick their thinking.
Yeah.
Not just for their benefit, but for the benefit of everybody else around them who might be sitting there thinking, well, okay, I get that Becky understands it, but I don't know how she got that answer. So, yeah, I think for everybody's benefit, there's opportunities there, aren't there, to really go a little bit deeper.
Yeah, definitely.
One of the other things that I thought was important to flag was that this isn't, although we've just talked about it in a Year 6 context, this isn't just something that is for, children who are in Key Stage 2 or Key Stage 3 or Key Stage 4. But these principles start from even preschool, that and perhaps we're intuitively slightly better at doing it with children at that young age, but whether that's intuitive or intentional, it's really important to have those conversations with very young children as well, just to get them to start thinking about their own thinking a little bit, even if you're not making it explicit that that's what you're doing.
Yeah.
But just asking questions like, what do you notice, and why is that, and those sorts of things are, drawing attention to things to help them make those connections from a very young age.
And I think you do automatically do it with younger children, because you're trying to help them understand the world, aren't you? So you're asking questions all the time and getting them to talk back to you about things. So I think you're right. And it was interesting what Nathan was saying, how actually he saw it more maybe in younger children, and it got lost a little bit along the way, which is a bit sad. But yeah, definitely. We've talked before, haven't we, about not underestimating children's ability to talk about their learning. And it's come up again.
I wonder whether it's anything to do with, we talk about younger children not having an internal monologue, and definitely as a dad of two who had two daughters that neither of them stopped talking between the ages of, I don't know, 1 and, well, the oldest one's 12 now. She has started to slow down a little bit on the talking to me side of things, but certainly young children don't necessarily have that internal monologue. Everything is said externally, whereas as you grow up a little bit, you start to internalize things more, don't you? And you start to be a bit more aware of what other people might think when you say things and things. So I wonder whether part of it is down to that. It's just that sort of societal change. And also, do we expect less talk as we move through school? Is there more periods of silence and things? Some of which is important to be able to concentrate and practice. But I think if you've got a classroom that's silent all the time, that's probably not a good sign.
No. Yeah, I agree. I think that talk is so important, isn't it? And just making sure that children are still feeling confident to talk about their learning too, as well as the adults. Obviously, it's not always easy as an adult to commentate on what you're doing, but once you get used to it, it is a really good thing to do.
Well, it's always nice when we've had this a few times recently. People have got in touch either via social media on LinkedIn or TikTok or Instagram, just to let us know what you've taken out of this episode. So if there's something that's really resonated with you, or just something that you think you might try in class, I think myself and Becky would both really love to hear that. So if you want to drop us a message, we're on TikTok at Primary Maths Podcast. We're on Instagram as well. You can find me and Becky on LinkedIn too. Are there any other places, Becky, that I'm failing to mention?
It sounds like we're everywhere, Jon. I think you've covered everything.
We are. Yeah, I think you can find us. If you look for us, you'll find us. You can leave us a comment on YouTube as well, directly under the YouTube video too, if you're listening or watching us on there. But it is great. Just the last couple of episodes, we've had some really nice comments about things that people have taken away from it, and that's really great to hear. It would be good to share some of those on future episodes as well. So if you have got something, do let us know. And if you'd like to find out more about Nathan's work or check out his books, head over to mrmetacognition.com. He's got blog posts, PD sessions, and loads of useful thinking prompts.
And remember, if you'd like the slide-ready summaries from today's episode, just search Primary Maths Podcast on Twinkle and download the free companion guide.
So, Becky, it's time for the resource of the week. And what have you got for us this week?
Well, John, this episode will air on what is, for some of our listeners, the last day of the school year, what's probably felt like a very long one. So hopefully our school-based listeners will be about to embark on a well-deserved break. But if you are one of those teachers who likes to get your classroom organised before you go off so you can properly relax, you might be thinking about your maths displays. So I'm going to share a popular resource today. And the resource itself is our place value strip display resource. I'm assuming there that most people are starting with place value in September, which are just the posters that you might put along your board or you might use for help with place value. But the main reason I'm highlighting it is because if you go to the resource page, underneath the green download button, there is a button that says see more versions. And I think it's a bit of a little known gem, to be honest. So if you click that, you will see we have a myriad of different versions, including botanical themed, pastel, different colours, editable, different languages. The list goes on. And there is a button to click. If there is one that you don't see that you would like, you can request it as well. So it can suit your classroom, whatever your theme is.
Very nice. I was always one of those teachers that had great intentions of being completely prepared for the autumn term, you know, on sort of the last day when children might be getting, well, I was in year 6, so getting the shirt signed and all that sort of stuff. I thought, yeah, I can sort out the classroom. Probably 15 years I thought that and never quite managed it. So, yeah, which camp are you in? Are you getting things ready beforehand, or are you, oh God, we're going back to school next week, I really have got to go in and sort my classroom out?
Well, I like to think that I'm in the first camp. However, as I went through my career, I realised that if I left it until I was fresh, I was probably twice as productive. So trying to tackle it. Yeah, trying to tackle it at the end of term when I was tired and on my knees and hot, I didn't get anywhere near as much done in a half a day or a day as I did if I went in just before we went back, where I was nice and fresh and rested.
No, much better just to sit and make a start on the boxes of chocolates that I've been bought that day instead. And, you know, put some thought into it.
Yeah.
Just get it clear in my mind what I wanted the classroom to look like for September.
Exactly.
That's all I was doing. Thank you for providing that fantastic excuse for me there, Becky. Well, that's just about it for this episode. Thanks so much for listening.
If you've enjoyed today's show, please do share it with a colleague. You can also leave us a rating or review. It really helps new listeners to find the podcast.
I'll be back next Tuesday on the Primary Maths Podcast. Becky is going to be taking some well-deserved annual leave, I think.
I am, thank you, John. I hope you won't be too lonely without me.
No, I'll try and just talk to myself for a bit. I'll be fine. So tune in next week to see how that goes. And until then, thank you so much for listening and have a great week if you are still in school. If not, I hope you are enjoying your summer holidays.